Hello friends, and welcome to puzzle 8 of 150. Let's see what Advent of Code has in store for us today. Day 8, Matchsticks. Space on the sleigh is limited this year, and so Santa will be bringing his list as a digital copy. He needs to know how much space it will take up when stored. It is common in many programming languages to provide a way to escape special characters in strings. For example, C and even PHP handles special characters in a very similar way. However, it is important to realize the difference between the number of characters in the code representation of the string literal and the number of characters in the in-memory string itself. There are some examples. So a string which is just 2 quotes is 2 quotes in the code literal, but in memory it will be 0 characters. All right. A string with ABC, so 3 characters, is actually 5 because of the quotes, and 3 characters in the in-memory. And then there's the escape sequences that we need to take into account, like slashes, /x for a hexadecimal. Let's say Santa's list is a file that contains many double-quoted string literals, so every string will be at least 2, 1 on each line. The only escape sequences used are // which represent a single backslash, / double quote for a single double quote, and /x plus 2 hexadecimal characters which represent a single character with that ASCII code. All right. Disregarding the white space in a file, what is the number of characters of code for string literals minus the number of characters in memory for the values of the strings in total for the entire file? All right. It goes on with another example part. Let's take a look at our input. So we see a lot of strings, quotes in the beginning, and then escaped sequences inside. So this would be a hexadecimal one. So yeah, we could, the first part seems quite easy. Just read it and count the size of the string, as that is the code representation of the string literal. And then we need to figure out how to do the escaping of characters. I'll make it a little bit bigger. I don't think it makes a lot of sense to try and force Java to actually read the characters for what they are, like processing the hexadecimal part. It seems that we can just get away with substitution, i.e. taking this value and substituting it with one thing. Same here, those 2 characters become one thing. Let's quickly scroll through it to see if there's any special ones. Here's the single backslash. Do we have like many backslashes? All right, here's a nice case. Single backslash followed by a hexadecimal one. So yeah, I think we should do some string replacement. That should be nice. Here is a very nice case. 2 single slashes following each other, being escaped by single slashes. So yeah, all right, let's give that a try. Let's use a function interface that takes a string and returns a string, and then way we can apply all the modifications that we want to do. So a function interface from Java U to function. What is the thing it takes? What is the thing it returns? Or the other way around, I always forget. Let's first create one that just returns the string itself. We'll call it the no operation function. So that would just be a function that takes a string and returns that same string. Yeah, and we'll make a function that Yeah, let's give this a try. So for each entry in the input list, we can stream over it and then apply this one function to it, and that should actually count the number of entries. Yeah, so let's yeah. So what we can do is we can create functions that do these transformations, and then using a Java 8 Lambda we can apply those, and then from that result count. So that would be something like this. With this, we have counted all the string literals in the code representation. The nice thing of functions is that we can chain them together, so we can say knob and then. So we can use that and chain our modification. So we figured out counting the code literal is quite straightforward. So we can just do int code literal comes that, right? So that's part one. And then the result will be string.value of code literal minus in memory. And in memory is nothing yet, so in memory will become, we'll start at 0. So the next thing we'll want to do is to create a bunch of transformations on the string literal that comes into our neat little code, and then count the result again. And that means that we will have to reuse this part right here, and let's make a function for it so that we don't have to repeat ourselves. So the first thing is just to count. This knob will actually do nothing, but this allows us to start chaining functions. So we said that we would then say, given the string s, we will replace all, which takes a regular expression. And the first one would be to say that double quote at the start will be replaced with nothing. Yeah, there we go. And then the one at the end would also need to be replaced. That would be a double quote at the end. There we go. Will be replaced with nothing. Now we need to take care of slashes. So the result of this is actually 2 underscores, which means that in order to replace a single escaped slash in the source string, we actually need 4 slashes in our replace all. So next one would be the escaped quotes. Oh, we escaped the slashes, so add with the X and then 2 digits, and that will be something else as well. What character is available? Percentage. All right, the only thing that I'm not very sure about is this part here. I guess we're done already then. Let's give our real test a try. 1333. Yeah, that's right. That's right. So let's update the test case. Now let's go the other way. In addition to finding the number of characters in the code, you should now encode each code representation as a new string and find the number of characters of the new encoded representation, including the surrounding double quotes. For example, an empty string, so 2 double quotes, encodes to... Alright, so we now need to encode the encoded string. Your task is to find the total number of characters to represent the newly encoded strings minus the number of characters of code in each original literal. So this is the no-op counter, and then we need to basically do the inverse of what we did, was instead of removing things, we add things to it. We only need to count the length, so we don't need to make a real representation, so we can replace this. Alright, luckily it is not correct. -4. Maybe I'm doing it the wrong way around. Should learn how to read. So I updated part 1 instead of part 2. So the answer should be 2046. Let's see if that's right. 2046. Right! Wow! That was great. Alright, so today's puzzle was not very big like last puzzle, so that's good, I guess. I think we found a really nice, clean solution for it. So let's see what the next puzzle has in store. See you later!